In this video, we're looking at problem 10.5, where we're going to calculate the internal rate of return from our Powerball deal in question 4. Now, we know from question 4 that the net present value with a discount rate of 8% is positive. Now, the way to think about this is the discount rate is the opportunity cost of not investing this $20 million somewhere else. So you could have invested your $20 million and earned 8% over 25 years. That's what we're assuming. So we can also think of the discount rate as the cost of your capital. It's costing you 8% return in order to invest it in this Powerball deal. And we know, since we've already calculated that the net present value, or the gain in value you're going to get from this deal, is over $1 million, we have to know that the internal rate of return is over the discount rate of 8%. So it's something over 8%. We know that for sure. But let's figure out exactly what it is. So let's take our cash flows from problem 4. The initial cash outlay of $20 million plus 25 years of $2 million a year. And let's copy that and put it in our problem 5. Okay, and we can see that our internal rate of return is something over 8%. It's actually 8.78%, and it's actually the exact internal rate of return that's going to give us a net present value of 0. So this is what we would need. This is what would the cost of a capital would be in order for us to exactly break even, not lose and not gain from this deal. And you can see, if I click on this cell and then go up here, you can't see it on the video, but I'm actually going to show the full answer. So this is the actual exact IRR to give you a net present value of 0. But for your answer, you only need to just, wrong way, you only need to just say 8.78%, okay? Now, what's cool about this is that we can go back and we can say, okay, let's just prove this out. So what this tells us is that any discount rate under the internal rate of return is going to give us a positive net present value. So let's just see if that's true. So we come back over here to our net present value problem, and let's put in 8.6, and you can see we're still positive. It's not as high, but we still have a positive net present value. We put in 8.7, we still are positive. And even if we put in 8.78, we're still going to be slightly positive, because the actual internal rate of return is 8. If you remember, let me jump back over here, get that thing out of the way. If you remember, is actually 8.78 plus, right? Plus a whole bunch of other numbers. So this is 8.78000000, which is what we put in over here, is going to still leave us slightly positive. So we can see that as long as the discount rate, or the cost of capital, or the opportunity cost for investing somewhere else, is lower or equal to the internal rate of return, then we should do this thing, right? Now, if we had a discount rate, for example, of 10%, if you could take this $20 million and invest it somewhere else at 10%, then you would be foolish to do this deal, because this deal would be, you would end up with a negative net present value of almost $2 million. So that's why the discount rate is very key, is the most important you really need to understand before you embark on an investment or a project, what your cost of a capital or the opportunity cost of using that money for for either a deal like this or a project. You need to really know what that is. Okay, so that is problem 10.5, internal rate of return. And once again, just real quick, you don't need to put this whole, just 8.78, wrong way, 8.78% is fine. Okay.